Okay, this is LI.C20. Li is on linear independence, and basically it refers to a span or a set of vectors. Sets of vectors are either linearly independent or linearly dependent. And based on its definition and the theorem that describes it, what we have to check is this. If we were to build a system out of this by using a coefficient variable and adding these guys up and setting it equal to 0, in essence, if we were to build a homogeneous system out of this, and it only has the trivial solution, it has no other interesting solutions, but only the trivial one, then this set is linearly independent. That's basically what it means. So to check on linear independence, you're basically solving homogeneous systems. And in our case, it's even easier. Because this is a square matrix, I can actually check it for singularity. And if it's non-singular, then it works. So let's write down first what we're really doing just to give you a chance to see this whole idea of linearly independent. So if I take alpha 1 times 1, negative 2, 1, plus alpha 2 times 2, negative 1, 3, plus alpha 3 times 1, 5, 0. And I set that equal to the zero vector. Then this system can only have the solution for alpha 1, alpha 2, and alpha 3 of 0. Alpha 1 equals 0, alpha 2 equals 0, and alpha 3 equals 0 in order for it to qualify. So that's what I have to check. I have to check what these variables need to be. In essence, I have to check on the null set of this particular matrix built out of these three vectors and see if that null set is trivial. Or if you think about it, because this one's a square matrix, I can just check it for singularity. That's the method I'm going to choose because it's the easiest. So I'm just going to write a single matrix as if we welded these guys together. Because it's a square matrix, I can check it for singularity or non-singular, and because of that, I can then judge what the null set of it's going to look like. So when we put this in RF, what we get is 1, 0, 0, 0, 1, 0, 0, 0, 1, which is perfect. Because this is the identity matrix, that means this is non-singular. Non-singular means it only had the trivial solution, and having the trivial solution means that this set is linearly independent. Now, I could get away with it this time because this was a square matrix once we built it. But if the set had been wider or taller, I wouldn't have been able to use this. I would have instead had to check on the solutions to the linear system. I would have still been basically checking on the null set, but I wouldn't have been able to use this trick in order to do it. I would have had to go a little bit further, okay? So that's it. This set is linearly independent because alpha 1, 2, and 3 are all 0, and that's the only solution.